I'll show you on Canvas again as we go. You're able to still see the lesson if you need to, if you wish, so that you're not behind. So we are going through section 1.1. So I'm just putting, these are notes for 1.1, and it's just on expressions and formulas. Please let me know if you can't see or can't read something that I write up here. So this first chapter is, like I said, it's review from Algebra 1. So today is going to be a review of evaluating expressions and using formulas with order of operations. So I know you're familiar with order of operations. I do want to stress, though, in this chapter, just because it is review doesn't mean that you shouldn't be doing the practice or shouldn't be fully paying attention, because you want to make sure that while it is review, that you do actually understand it. And while it is review, some of the examples that you would see in Algebra 2 are definitely more challenging than you would see in Algebra 1. So just keep those things in mind, that it's still good to, I guess, participate in the review and do the practice. You will have work time today, make sure you're using it. So I first want to review order of operations. I already heard somebody whisper, when you think of order of operations, what do you think of? PEMDAS. So I'm not going to write, well, I will eventually. I'm going to put PEMDAS into 4 rather than kind of the 6 letters that are used. I'm going to put it into 4 steps. So the P in PEMDAS stands for what? Parentheses. So I would group that together, or just rather a more general step would be evaluating everything inside of all grouping symbols. Parentheses are the most common grouping symbol, but they're not the only grouping symbol you will see. So we do have parentheses. What else would you see as a grouping symbol? Brackets. And then there's one other that you don't see as often. Yeah, the braces. I don't know if this is what you mean. They're like the curly brackets. That might be hard to draw. If you just put like a squiggle, if you have to make your own curly bracket, as long as I can tell what it's supposed to be, then you're okay. All right, so all grouping symbols, I know you think of that as parentheses. What does the E stand for? Exponents. So you could put exponents, I'll put powers. And then I'll put exponents after, but this is a good time to kind of talk about the difference between the terms power versus exponent. So when you have an expression that has an exponent, like I'll put up here, I'll put 3 squared. So the exponent is specifically the 2. But if we talk about a power, the expression as a whole is a power. So the entire expression is a power, whereas an exponent specifically refers to the 2. Just so you understand the difference between those terms. And then what do the M and the D stand for? Multiply and divide. So I would put those together in the same step. So multiply, divide. Because you multiply and divide from left to right. So you do not always multiply first and then divide. If you see multiplication and division is first, you divide first and then you multiply. So it does go from left to right. That's probably where the most mistakes are made, is students wanting to multiply first if they see both operations. Same for the last 2, A and S stand for what? Add and subtract, and that's the same rule. It's from left to right. So if you see both addition and subtraction, but subtraction is first, you do subtract first. Okay, so then I just have some examples that we'll go through together, some that you'll just kind of work through on your own and make sure you get the right answer. I do require for problems where you're using order of operations that you are showing a series of steps. So I'm not saying you can't use your calculator because there are some problems where you might have, for example, like a decimal raised to a power, and I don't expect you to do that in your head. So you can use a calculator for individual steps, but I need to see some steps. I don't just want to see a problem and then see the answer because you typed the whole thing in your calculator. That's not actually practicing order of operations. So all of these directions are going to say evaluate, not solve. You evaluate an expression, you solve an equation. An equation has to have an equal sign. You will not have equal signs in these expressions today. So the first one is evaluating this expression m plus the quantity in parentheses p minus 1, and that quantity squared. We're evaluating this if m is equal to 3 and p is equal to negative 4. So this would be an algebraic expression versus a numeric expression. Algebraic expressions include variables. If it was a numeric expression, you would just have numbers. So when you have an algebraic expression, in order to evaluate this, what do we have to do first? We do have to do the parentheses before that. Yep, you have to put the numbers in. You have to substitute the numbers in. So again, I know this is review, just making sure we're all on the same page. So I have to put the 3 in for m and the negative 4 in for p, and then I can work with the parentheses first. So I have 3 plus the quantity negative 4 minus 1 squared. And now in the parentheses, and I would say for these types of things, try not to use your calculator. I realize we get so reliant on calculators, we start typing things in, but try to practice your mental math. Negative 4 minus 1 is negative 5. Okay, and then we would do what? We have addition, we have an exponent, so exponent power next. 25. Negative 5 squared is 25. Plus 3 equals 28. Okay, and then this negative 5 squared, I also want to take a minute to show you something on the calculator. I'm sure you've been shown this before. Just have to grab my calculator here. This is also an easy mistake that is made when we just get into the mode of typing things in our calculators and then not really paying attention to the answers we get and whether or not they make sense. If I just type in negative 5 squared, my calculator tells me it's negative 25. Yes, you need the parentheses. If you're typing a negative number squared in a calculator, you have to put parentheses around it, or your calculator will tell you it's negative. What your calculator does, it does follow order of operations. So the calculator is taking the 5 squared first, which is 25, and then taking the opposite of it, which is negative 25. If I actually want negative 5 squared, I have to put parentheses negative 5, close the parentheses, then squared, then it will give me the right answer. So just to be aware of that when you get into that mode of just typing things in, make sure that it does make sense. Because even if it's your negative symbol off, if I had negative 25 here, I have a completely different answer and it's wrong. So just be careful of that. Any other questions? We're probably good. Here's one just for you to do without me and then see if we all get the correct answer. So evaluate this expression, the quantity x minus y cubed to the third power, and then plus 3 if x is equal to 1 and y is equal to 4. So just work through that example. I'll give you a couple minutes. We'll check it, see if we all get the same answer. Check in your groups, see if you all get the same answer. If you don't, try to figure out why. Walk around, I just want to make sure you have time to get an answer before we do it. All right, I'm seeing, just as I walk around, I'm seeing some different answers even within groups. And I heard some groups talking about it when they were coming up with different answers. I think the two common answers I saw were positive 30 or negative 24. One of those two is correct, one is not. So the correct answer is negative 24. Okay, so if you had positive 30, this may have been what you did. You substitute in the values. 1 minus 4 is negative 3. Negative 3 cubed is negative 27. Because you have negative 3 times negative 3, which is positive 9, times negative 3 is negative 27. And then plus 3 is negative 24. Okay, any questions on example 2? All right. I'm going to skip ahead to this one on my sheet. So I have x to the 4th minus 3wy all over y to the 3rd plus 2w. And this is if w is equal to 4, x is equal to negative 3, y is equal to negative 5. So sometimes when we have expressions that are fractions, there's some mistakes that are made. So go through one of these. Give everybody a chance to write it down. We know the first step is to substitute the values in for the variables. So also notice how I write this. So when I have x to the 4th and I know x is negative 3, when I write that, I will put the negative 3 in parentheses to the 4th power. So if you were to type this in your calculator, you would want that negative 3 to be in parentheses. Because if you don't write the parentheses, it does mean something different. You saw on the calculator, you would get a different answer for this one. The wrong sign, I should say. And then minus 3. When you just have numbers and letters written next to each other, what operation does that mean? Multiplication. So 3 times w is 4 times y is negative 5 all over negative 5 to the 3rd. I also put that negative 5 in parentheses plus 2 times w is 4. And now here, you can, or what I find easiest with fractions is simplify the top of the fraction, the numerator, using order of operations, simplify the denominator of the fraction using order of operations, and then once you have just one number in the numerator and denominator, then simplify the fraction as a whole. So we're going to kind of be, you can kind of combine some steps as you go as well. So along the top, we do have an exponent, and then we have subtraction, and this is all multiplication. So I really could, if you wanted to, this is fine. I don't need to see every step like in separate lines, if you want to think of it that way. Because in this one, I could do the exponent and I could multiply these in that same first step, and that's fine. So what is negative 3 to the 4th? 81. It is positive. And then I have minus, and I could multiply these just because it's kind of separated from that exponent. So I could do that in the same step. 3 times 4 is 12. 12 times negative 5 is negative 60. So I have 81 minus negative 60. And what happens when you subtract a negative? Turns positive. So plus the positive, or just changes to addition. On the bottom, I have negative 5 cubed. What is that? Negative 125. It is negative. And here too, I have plus. I could do the multiplication right away as well. 2 times 4 is 8. So I have 81 plus 60 in the numerator. That would be 141. Denominator of negative 125 plus 8. Okay, and in Algebra 2, this might be different from in geometry. When it comes to fractions and decimals, you can always leave your answer as a fraction. Just make sure it's simplified. You can leave it like this is improper. The numerator is larger than the denominator. You do not have to change it to a mixed number to simplify it. You can leave it improper. Simplify just means that the numerator and denominator don't share any common factors. So if you can divide them both by something, you should. You will lose points for not simplifying. All answers should always be simplified, put in simplest form. So you are always able to leave an answer as a fraction in simplest form. You can sometimes change fractions to decimals. And here's where I am fine with you changing it to a decimal, and then where I don't want you to change it to a decimal. If I take 141 and I divide it by negative 117, I get a repeating decimal. So fractions are always going to be either repeating decimals or they'll be decimals that terminate, like 1/2 is 0.5. It terminates. If it's a repeating decimal, I want you to leave it as a fraction. Because if you write the decimal, you are then approximating the answer and it's no longer exact. If it was a terminating decimal, like I said, 1/2 is 0.5, then I'm fine with you giving me 0.5 because 0.5 is exact. Does that make sense? So I just always want exact answers. I don't want approximated answers unless the directions specifically say approximate to the nearest hundredth or whatever that might be. So I usually will leave answers as fractions unless we have to use them in a problem and I can change it to a decimal. That's, in that case it's fine. So here I just have to determine, I'm going to leave it as a fraction. I have to determine if I can simplify this. Which I will tell you, you can simplify this. You can have negatives in a fraction. So what this means is, since the numerator is positive, the denominator is negative, that just means the fraction as a whole is a negative number. So you could write this with the negative symbol in front of the entire fraction. If there was a negative on the top and the bottom, those would cancel out. It would then be positive. I could also just change this and put the negative symbol on the top instead of the bottom. So that negative symbol, if you want to, you could just put it in front. It just means it's negative. Anybody know, have you been Oh, you just have it? What did you have? It is negative 47 over 39. So that would be, I'm just going to divide by 47 here. So they can both be divided by 3 to get this answer. Okay, so just make sure your answers are always in simplest form, especially when you leave them as fractions. Okay, I have one other example. I'll have you do this one without me. While you're working on it, I will pass out your assignment that you can then, you have the rest of the class time to work on. And then we'll also check this answer, make sure you're all getting the right answer. So this one is j squared minus 3h squared k all over j cubed plus 2. And that's if, I'll move this up here, h is 4, j is negative 1, k is 0.5. So evaluate it. You can check in your groups. Did you all get the same answer? If not, why not? And then I'll